Good afternoon, everyone. Today we're going to be talking about section 4.3. Now we're only going to be talking about one portion of this section, but this entire section is on quadratic models. Okay, so the first thing we're going to talk about is forms of these quadratic functions and their graphs. Now we have the parent function here, f of x equals x squared, and x squared is the simplest quadratic function. So if we were to look at a table of values for this, we would see that the x's are all of the values that we could, if we continued this out, positive and negative, but our f of x, our output or y values, are positive numbers. Okay, so here's the graph of this function, and as we can see, all of the y values are positive, 0 and above. So the domain for this function, for any quadratic function, is always going to be all real numbers. All right? For this particular parent function, the range is going to be everything bigger than 0. So we can say y values such that y is greater than or equal to 0. And we can see that here, this graph does not go below the x-axis. So remember that this graph is called a parabola. And there's some features of a parabola here that are true for any quadratic function. So all parabolas are going to have an axis of symmetry, which is you can think of it as a line that goes right down the center of our parabola. And in this case, for our parent function, x squared, this is the y-axis, and our axis of symmetry will always be an equation, and it will always be x equals some number, and so in this case it is x equals 0. Right? We'll always have a minimum point. In this case, our minimum point is right here at 0, 0. It is the lowest point of our graph, so this is our minimum point. It is the lowest point of our graph. And again, in this situation, that minimum is at 0, 0. And we also call this the vertex. Okay, the vertex is the lowest point of our graph when it is facing upward. All right? So we're going to look at some graphs quickly to see what happens when we do some things to this parent function. So the first thing we're going to look at is what happens when we multiply a number by our parent function or when we add a number to the end of it. So these are the investigations on page 153. And what I would like you to do on your calculator is to graph these equations here on the same graph and to see what happens when you multiply those different numbers. So please do that and then come back to the video. So as we can see here, the blue graph right here is our parent function, x squared. And then we have 3x squared and negative 0.5x squared. So as we can see, multiplying a number to our parent function changes the graph a little bit. Multiplying a number bigger than 1 makes it a lot skinnier. Multiplying a number smaller than 1, if it's negative, it makes the graph go below the x-axis. And if it is a fraction like 0.5, makes our graph wider. So if I flipped this graph up, we would be able to see that it is actually wider than our parent function. Okay, so I would like you to do the same thing with these graphs here to see what adding or subtracting a value onto the end of our parent function does to our graph. So after graphing these, we can see that the plus 2 made our graph go up by 2 points, and the minus 4 made our graph go down 4 points. So adding a value onto the end of our parent function makes our graph go up or down. Right? So let's just make note of that. And we're going to do that by taking note of what different parts of our general form of quadratic equation do to that equation in that graph. So our general form of a quadratic equation is this. So So our general form is ax squared plus bx plus c, where a, b, and c are elements of the reals. So this symbol means an element of, and it just means they are real numbers. Okay, and a cannot equal 0. Now, very quickly, I would like you to think of why can a not equal 0? And I'm going to ask you that in class next time I see you. Okay, so we saw that multiplying a number in front of our a value, in front of the x squared, changes the shape of the graph by either making it skinnier or wider or flipping it up or down. So that's all on our a value. So we're going to write down what these different values do and what we can find from these different values. All right, so our a value, if a is bigger than 0, a couple things happen. We're facing up, which means that we are concave up. And if it is bigger than 1, in particular, that means our graph gets skinnier. All right. If our a is smaller than 1, so if a is a fraction between 0 and 1, a fraction, that means we're going to get wider. Okay? If a is smaller than 0, so negative, means we're going to be facing down and we are concave down. All right, so that's what multiplying a number to x squared told us would happen. Now adding a number onto the end of x squared moved our graph upwards or downwards to that point. So we can see we started at 0, 0, this moved up to 0, 2, this moved down to 0, negative 4. So our graph is going to intersect at the point 0, and then whatever this last number, the number we're adding onto, is. Okay, so that's the y-intercept. Now the b value in the middle here is very important because it tells us where our axis of symmetry is. Now remember, all parabolas have an axis of symmetry. When we're talking about x squared, it is on the y-axis. When we're talking about any other general form, quadratic equation, our axis of symmetry is going to be the equation x equals negative b over 2 times our a value. And remember, a cannot equal 0. And don't forget to answer that question. Why cannot a not equal 0? Right? This value also gives us our vertex. It gives us the x value of our vertex. Because since our vertex is our middle point here, either our minimum when we're concave up or our maximum if we're concave down, that axis of symmetry goes right through our vertex. Okay, and to just get the y value of our vertex, we would just plug in that number into our equation. So that's our general form. That's what the different parts of our general form tell us. So let's look at another form of quadratic equation. So before we look at the factored form, or another form, I would like you to please do this investigation on page 155. So I would like you to graph this equation, y equals x minus 1 times x minus 3 on your calculator. So the factored form, or factorized form of a quadratic function is a times quantity x minus k and x times x minus l. And you might see that k and l as different letters, but x minus some number times x minus some number. Okay? So when we look at the graph of x minus 1 and x minus 3, what we want to focus on is where we see these negative 1 and negative 3 on our graph. And I can see them right here and right here on our graph. And that's where our parabola crosses the x-axis. So these are our x-intercepts. But notice that this goes to a positive 1, and this one goes to a positive 3. And the reason, because remember on the x-axis, y equals 0, so the x-intercepts are at 0 or 1 and positive 3 instead of negative 1 and negative 3 because these two parentheses must equal 0. And if I solve, I would get the opposite values. And the reason they must equal 0 is because for y to equal 0, that means this entire equation must equal 0. And the only way two things can multiply and equal 0 is if one or the other equals 0. And just so you remember, that's called the zero product property. Right, and we'll talk more about that when we get to solving quadratic equations again. So let's look at the different parts of this equation, just like the regular form, the general form. Everything about a is the same. So when it's bigger than 0, our graph is concave up, smaller than 0, concave down. And remember, if a is a whole number bigger than 1, our graph is really skinny, and if it's between 0 and 1, so a fraction, it's going to be wider. Now, in the general form, we could find the y-intercept, where our graph crosses the y-axis. And in the factored form, we're going to see the x-intercepts. And as we can see, we have 2, and they're going to be at k0. Remember, that is opposite, so you take the opposite of the value you see in parentheses, and L0. And it's the opposite because you need to see what value would make that parentheses equal to 0. Now our axis of symmetry again is right in the middle of our parabola, and it's actually right in the middle of our x-intercepts. So we can find our axis of symmetry. And remember, since it is a line, it has an equation. It's always x equals. We can find it by averaging our x-intercepts. So by adding k and L together and dividing by 2. And again, remember that this is the x-coordinate of our vertex. So it's at k plus L divided by 2, and then we would plug that in to figure out our y-coordinate. Now let's talk about our last form of quadratic function. Now this form is called our vertex form, and this should be pretty clear to you once we look at an investigation here. So our vertex form, I'm actually going to change it, x minus h squared plus k. So we're going to see what these two parts do to our graph. So what I would like you to do is I would like you to graph these equations on the same graph. So x squared, our parent function, x plus 2 squared, and x plus 1 squared. So once we graph these three equations, we can see what the values inside our h value does to our parabola. So we can see that the plus 2 actually made our graph move to the left 2 to negative 2, while the minus 1 actually moved our graph to the right to positive 1. So just like our x-intercepts were opposite of what we saw in parentheses, our vertex is shifting the opposite direction we would think. And again, that's because we want that parentheses to be equal to 0. So we're thinking, okay, what value would make that parentheses equal to 0? So now I would like you to graph these two equations here. So x plus 2 squared minus 3 and x minus 1 plus 5. So now we know what this plus 2 and this minus 1 do. So we're going to be taking a look at what happens when we add something onto the end there. So now that we know what the negative 1 and the positive 2 do to our graph, we can see now from up here, our graph, that minus 3 has shifted our graph down 3. Just like this minus 4 on our general form shifted our graph down 4. And the plus 5 shifted our graph up 5. So this k value shifts our graph up and down, like our c value in the general form. So just like in all of our other forms, if this a value in front is bigger than 0, we're concave up. If it's bigger than 1, then it's skinny. If it's a fraction, then it's wider. If it is less than 0, so negative, then our graph is concave down. Our h value shifts our graph left or right. And it shifts it to the right when inside the parentheses is negative, and it shifts to the left when inside the parentheses is positive. So remember just to make it the opposite value. And our axis of symmetry, because it goes right down the middle of our graph here, actually equals h. So remember, it's just going to be the opposite of the h value we see in the parentheses there. And our k value shifts our graph up or down. So our vertex actually ends up being at the point hk. Just remember, it's the opposite of the values we see in that parentheses. And I'm also going to write down that k shifts our graph up or down. Okay, so those are the 3 forms of quadratic equations. We have our vertex form, our factored form, and our general form. We will practice graphing these tomorrow during class.